Good morning, everyone. My topic is PFC needed. So, why PFC is needed? It is needed because it's reduced power efficiency, increased current draw, and increased energy cost. Here are the types of PFC. Passive PFC. This method uses passive components like capacitors and inductors to compensate for the reactive power in the circuit. It is typically used a lower power application but it's less effective than active PFC. Active PFC. This method employs a switching converter to actively shape the input current waveform to be closer to a sine wave, thereby improving power factor. Active PFC is more complex and offer higher efficiency and better performance. So what is the difference between passive PFC and active PFC? So passive PFC uses single components like inductors and capacitors to improve power factor, but it's less effective and only suitable for low power applications, while active PFC uses more complex circuitry and control system to achieve a much higher power factor, make it ideal for high power devices. Think of it like a passive PFC is a simple band-aid, while active PFC is a major surgery. Both fix the problem, but one is far more effective and sophisticated. So here are the illustration of power factor correction. The diagram shows that the circuit diagram this shows a simple PFC circuit used to improve efficiency and electrical power usage. It includes inductor or L1, resistors for R2, capacitors for C1 and C2, and the filter, all working together to correct the power factor, and the line input is represent to the incoming power and the load represent to the device using power. The beer mag analogy. The beer mag represent electrical power. The beer itself usable electricity, and the real power used by the device. The foam on the top wasted electricity. It represents reactive power, which is power that's not effectively used and lost. VFC aims to reduce the foam reactive power and increase the amount of beer real power for better efficiency. So in short, the image illustrates how power factor correction improves electrical efficiency by minimizing waste power. Resonant converters. Resonant converters are a type of SMPC that utilize resonant circuit to achieve soft switching. Soft switchings refer to the turning the switching elements on and off when the voltage or current across them is close to zero, minimizing switching losses and improving efficiency. So how resonant converters work? Resonant tank circuit. Resonant converters incorporate a resonant tank circuit consisting of an inductor and a capacitor turned to resonate at a specific frequency. This circuit stores and releases energy at the resonant frequency, enabling efficiency power transfer. Soft switching. So by operating at the resonant frequency and switching elements can be turned and off when the voltage or current across them is close to zero, minimizing minimizing switching losses and improving efficiency. So the zero voltage switching or ZVS or zero current switching Z, ZCS, the resonant converters can achieve either ZVS or ZCS depending on the circuit topology and operating conditions. So here are the resonant converter figure. The image shows a zero voltage switching resonant converter. It is a type of power electric circuit that efficiently convert DC voltage to another DC voltage. The diagram breaks it down into two parts, a resonance circuit involving inductor L and L1 capacitor, C and C, C and C1 and diodes D1 and D2, and a filter circuit with capacitor C1 and resistor R. The switch S controls the power flow. This design aims for efficient energy transfer by switching at zero voltage point, minimizing energy loss. So here are the examples of resonant converter application. High power application. Resonant converters are often used in a high power application like electric vehicle charging, solar inverters, and industrial power supplies. Telecommunication equipment. Resonant converters are used in telecommunication equipment like base stations and wireless communication devices, where high efficiency and low EMI are critical. Medical equipment. Resonant converters are employed in medical equipment like MRI machines and X-ray generators where low EMI and high reliability are essential. So that's all. Thank you.